Hello and welcome to this presentation on the final project we did for courses CSC E63 Big Data Analytics 2014 in the Harvard Extension School. The topic of the project was Scoop, a mechanism for transferring data to and from the Hadoop database data file system. So in this slide we show what was the scope of the project, what are the various resources we used, and the software installed to get this to work. The scope basically included importing data from SQL Server to Hadoop and exporting the data back from Hadoop to SQL Server. Importing data from SQL Server to Hive and exporting data back from Hive to SQL Server. And finally, importing the data from SQL Server to HBase. The resources that were used were Windows 7 platform, the 64-bit OS, MapReduce version 1 in Linux VM, CentOS Linux VM basically, and a SQL Server Express 2012 database instance created in Amazon Web Services using their RDS service, and a local on the SQL Server Management Studio installed in the client PC to connect to the DB instance, and a third-party tool SQL data generator from Redgate software to create the test data. And the software that were installed in MapReduce Linux VM were Scoop, Hive, HBase Master, and they were all installed using the yum command. I also set the environment variables so that the commands can be issued from anywhere in the VM. I also installed the SQL Server JDBC driver in the MapReduce Linux VM, and I chose this particular file, this tar file, this compressed tar file, and selected SQL Server 2012 Express in Amazon Web Services. After we launch the DB instance using a launch wizard, which is pretty much straightforward, we wait the instance from the state of being created to the state of being available, and you have to wait for a while to get there to the state. What this is showing is the detail of the DB instance once this has been in a state of available. I chose like a 20 gigabyte storage, which is more than enough. It was the minimum I had to choose. The security groups I chose were default active, and anything else I found out that I was not able to connect to the DB instance. And the instance class I chose micro to keep the cost minimum. And one thing we have to note here is the endpoint data that is here, which is showing the MySQL server, which is the name of the DB instance that I created, and the name of the server where the DB instance is running, and the port number, and is indicating authorized, meaning the DB instance will allow remote connection. So first we create the test tables, namely employee table and the student table in SQL data using the SQL Server Management Studio. These are fairly straightforward tables having only 3 columns. The employee table has the employee ID, the name, and the hiring date of the employee table, employees. And the student table has the first name, last name, and the graduation year. Once the tables are created, I connected to the DB instance using the SQL data generator tool, and it giving the same connect string, and it picked up those 2 tables that I just created, and it also created some sample data for me to see. So I had to set up all these parameters here. It gives the default value of 1000 and kept it that 1000, and I clicked on the generate data, and then it asks for confirmation. Once it's confirmed, it asks for confirmation whether to create data for both tables, and I say yes. So it creates test data for both the employee table and the student table, which I used in the rest of the exercise. So the first exercise is to import data from SQL Server to Hadoop. And the command that was used was scoop import. So we have to give the string using the connect attribute. And the string is the JDBC driver, the name of the instance, and the name of the server, the port. Exactly what we saw in that area where it says endpoint. Just copy and paste it over here. We give the username and the password, the username, data, the password for the instance, and the database that I picked up from the SQL Server where I created the table, employee table, and then I named a target directory file in Hadoop, which is employee info. So once I issued the command, it went through MapReduce cycle and created 1000 records, basically imported it from SQL Server, and wanted to see first 10 records how it looks like. And it shows that it has the employee ID in the first column, the name of the employees, and the hiring date. Next, we're going to export the data back to SQL Server from Hadoop. We issued the scoop export command this time. The connect string is the same. The name of the table to be exported to is the M table, and data to be exported in Hadoop is the export directory, employee info. So once I issued the command, it went through the MapReduce cycle, and it showed it exported 1000 records to SQL Server. Next, we import data from SQL Server to Hive. We use this import command, the same connect string, no change. The table is the same. We just do a Hive import, a Hive table, I call it employee info, and the attribute is append. It could also be overwrite, and fields terminated by tab character. First, we check to see whether there are any tables called employee table in Hive. So we go to the Hive prompt by typing just simply sudo hive, and it will, in Linux, it will take it to Hive prompt, and we show tables, and there we see nothing there. And then we issue the scoop import command, and we get to see the Hive import is completed successfully. Next, we check to see whether the data has been transferred to Hive from SQL Server. So from the Linux, we issue Hive, sudo hive, and it takes us to, and you can see that we need sudo to get into Hive because of restrictions, access permission, and that gave us some issues. We had to deal with some issues with access to Hive file systems. So it gives us the Hive prompt, and we do show tables, and now it's showing the emp info file there. And we wanted to see the structure of the file. It has the same structure, employee ID, first name, last name, and hiring date, and so on, just the way we created it. And it took about 78 seconds to do this, to get this data. And then when we find out how many records it has imported, and it shows that it has imported 1000 records. Now we export the employee information data back from Hive to SQL Server. So we use this export command using the same connect string. We have the employee table and the export directory. This time, when it comes to Hive, we have to issue the path where the employee information folder is. And this is the user Hive warehouse. We had to find this out, and I have included it in the environment variable so that Scoop can find this path. And the input fields are terminated by tab character. We issue the command, goes to the MapReduce cycles, and it shows it exported 1000 records back to SQL Server. So now we check to see the data from Hive to SQL Server, and it shows that it has 1000 records sitting in SQL Server. Next, we import data from SQL Server to HBase. So this time we're going to use the student table that we created earlier, and we ensure that there is no end label in the HBase, and There are indeed 1000 records in SQL Server. So what do? We go to Linux and issue hbase shell command, and it brings us to hbase prompt. We do a list command, and we see the table has 0 rows. And we go back, check the SSMS, the SQL Server Management Studio, and we see that SQL has only 1000 records sitting there, which is good. So we now issue the import command from student table data from SQL Server to student info in HBase. We use the SQL scoop import command. The same connect string, nothing changed. The same, the student table is a different table now. We have to identify the HBase table. Student info is where the data will be saved or exported to. And the column family will start with student ID, and the rest of the columns will be picked up because of the column family. And we have to create an HBase create table attribute, which we didn't have to use in the case for Hive. And then we get into this HBase shell, we are listing, we count the records, and we examine some sample data. So here we issued the command, and what we see that it has retrieved 1000 records, going to the MapReduce cycles. We go to the HBase shell, and we are in the HBase prompt. We issue a list, we see the table, student info is there, and 1000 records have been imported. And we examine some data. We see that the student info data files have picked up, collected the data student records with ID 995. Here's the student and her year of graduation. This brings conclusion of this presentation. I hope you have found this thing interesting. Thank you.